All right, unit number 9, statistics. This unit reviews the measure of center and spread of data. It explores the different methods of displaying data and describing how a value relates to the population. So, to get going today, we're going to start by watching a TED Talk to hopefully get you motivated to learn some statistics.
Well, if President Obama invited me to be the next czar of mathematics, then I would have a suggestion for him that I think would vastly improve the mathematics education in this country. And it would be easy to implement and inexpensive. The mathematics curriculum that we have is based on a foundation of arithmetic and algebra, and everything we learn after that is building up towards one subject. And at the top of that pyramid, it's calculus. And I'm here to say that I think that that is the wrong summit of the pyramid. At the correct summit that all of our students, every high school graduate should know, should be statistics, probability, and statistics. I mean, don't get me wrong, calculus is an important subject. It's one of the great products of the human mind. The laws of nature are written in the language of calculus. And every student who studies math, science, engineering, economics, they should definitely learn calculus by the end of their freshman year of college. But I'm here to say, as a professor of mathematics, that very few people actually use calculus in a conscious, meaningful way in their day-to-day lives. On the other hand, statistics, that's a subject that you could and should use on a daily basis, right? It's risk, it's reward, it's randomness, it's understanding data. I think if our students, if our high school students, if all of the American citizens knew about probability and statistics, we wouldn't be in the economic mess that we're in today. Not only that, if it's taught properly, it can be a lot of fun. I mean, probability and statistics, it's the mathematics of games and gambling. It's analyzing trends. It's predicting the future. Look, the world has changed from analog to digital. And it's time for our mathematics curriculum to change from analog to digital, from the more classical continuous mathematics to the more modern discrete mathematics, the mathematics of uncertainty, of randomness, of data, in that being probability and statistics. In summary, instead of our students learning about the techniques of calculus, I think it would be far more significant if all of them knew what 2 standard deviations from the mean means, and I mean it. Thank you very much.
Hopefully that kind of inspired you for this unit's lessons to get down and dirty with some statistics. This is something I have used at every single job I've ever had. It was by far my favorite math topic and class. And every major in college is going to require you to take a statistics course. So this unit is designed to help you get ready for that course. So 9.1, we're going to do categorical versus quantitative data. So we're going to compare and contrast categorical and quantitative data, and we're going to construct and interpret bar graphs and pie charts. So individuals are people, places, or things being measured or observed. So for example, people, animals, or diseases could even be considered an individual. Qualitative data, which is also sometimes called categorical, so this is the same thing, places an individual into one of several groups or categories. So some category examples would be their gender, any yes or no question, their hair color. All of this is a category. So it's qualitative. It's a quality that the individual has. Quantitative data is a group of numerical values for which it makes sense to find an average. So if it makes sense to find an average, that means the answer is a number. So their height, their weight, their GPA, All of these are a quantity, so it's considered quantitative. So it says to circle each quantitative variable. So starting at the top, gender is not quantitative, but height is. The number of hours you watch TV is quantitative. How many siblings you have is quantitative. The number of times on Facebook is quantitative. How many pets you have is quantitative. The number of times you exercise is quantitative. Your favorite sport is not. How long you study is. The number of video game systems is. The number of colleges you applied to is. The number of sports or activities you're involved in is. Your favorite subject is not. If you traveled outside the US is not. The month you were born. This is a little bit tricky. So, like for example, April is the number 4. That does not mean, though, it makes sense to find the average month that people were born. So, this does not make sense in a quantity way. It's considered a category of what month. Your favorite color is a category. The number of syllables in your first name is quantitative. How many haircuts per year you get is quantitative. If you have a driver's license, that's a category, and hair color is a category. Number 2, data from a medical study contain values of many variables for each of the people who are subjects of the study. Here are some of the variables recorded. We have gender, age, weight, race, smoker, blood pressure, and level of calcium in the blood. Identify each as categorical or quantitative. Categorical, again, is qualitative, same thing. So gender is a quality. Age is a quantity. Their weight is a quantity. Their race is a quality. If they're a smoker, that's a quality. Blood pressure, that's a number answer, it's a quantity. And the level of calcium in their blood is a quantity. Number 3, popular magazines rank colleges and universities on their academic quality in serving undergraduate students. Describe one qualitative variable and one quantitative variable that you might research for a school. So, a qualitative variable that we'd want to know about the college would maybe be where's their location? A quantitative could be something like how many students go there? Maybe you want to go to a small school, maybe you want to go to a big school, maybe the location matters to you. These are things you'd want to know about what college you're applying to. All right, so the next one, the question that I surveyed was, what is your favorite sport? I had 25 high school seniors respond to this question. So we have aquatics, track, volleyball, track, aquatics, baseball, track, volleyball, baseball, soccer, track, volleyball, aquatics, baseball, track, football, soccer, football, and wrestling. So we're going to make a bar graph. Notice this is a qualitative question of what sport do you like, not quantitative. So to make the bar graph, you have to put the sports at the bottom. I chose to put it alphabetical, but you could decide some other order. And then this is going to be scaled from 1 to 10 because everybody fits in less than that. So 4 people said they prefer aquatics. 4 people said baseball. 2 people said basketball. 2 people said football. And then golf, that was nobody. Soccer was 2. Tennis, nobody said. Track, 7 people. Volleyball was 3. And wrestling was 1. Again, the order of this really doesn't matter. There are gaps in here because nobody said golf and tennis, but it could have had a gap in the front or the back depending on where you put golf and tennis. So now number 5 says to find the percent of each response and then sketch a pie chart. So out of the 25 responses, 4 people said aquatics, so 4 out of 25. If you do 4 divided by 25, you get 0.16, but then you have to convert it to a percent. So you're going to move the decimal over twice and get 16%. Same percentage will be for baseball. Basketball's only 2 people out of 25, so that's 8%. Football's also 8%. Soccer's 8%. Track is 7 people out of 25, so 28%. And then volleyball is 3 out of 25, which is 12%. And then wrestling is just 1 person out of 25, which is 4%. So if we were to make a pie chart, notice that track is more than a quarter of the circle. Doesn't really matter where each of these goes. It makes sense to label which one each one is, but the order around the circle doesn't really matter.